What's going on, everyone, and welcome back. So, uh, today we are going to be doing parenting. So, in case you're completely new, parenting is just the relation between like an object that is supposed to be attached to another object. So it inherits its transformation. We've already done parenting in the past, but it was hierarchical parenting, which is not true parenting. So, hierarchical parenting, if you only want that, you don't want actual physical parenting, then you don't have to watch this. This is not going to be anything that you're going to be able to add to your own engine then. But you can watch it just to see how it's done. Not every game requires true parenting, but but it's good for a lot of the other games, like the old Mario Brothers, Zelda, stuff like that. It doesn't require or really need physical parenting, and well, yeah. So if you were doing something like that, then you don't even have to worry about it. True parenting actually costs a lot more to actually do it. So that if you don't want it, I wouldn't recommend adding it because you're just using power that could be used elsewhere. So, how true parenting works is every time you parent an object to another object or move a transformation of any object, you have to go through all of the children of that object and update their physical location. And that's where the problem kind of lies. I mean, there's ways you can kind of get around it so that you don't have to. For instance, if you're only using local position, like if you only care about local position, uh, then you can like scroll down the parent objects and then adjust the local positions based on parenting and stuff like that. But it's actually a lot more work doing it that way, and it doesn't save you anything. You're pretty much just doing the same crap, just in a different way. So, in this episode, again, I'm going to have to just talk about the code and show you the code because, as you can see, my internet is still not back up. It's like sporadic. It'll pop on for like an hour a day or something. Then it'll just like go away, and then it'll come back for a couple minutes and go away later on in the day. I don't know. It's really stupid, and I gotta go. Like, I need to get that taken care of. It's really, really frustrating because it's been out for what, 2 weeks, a little over 2 weeks or something. And yeah, internet is just way too expensive to be paying for something you can't even use. So we can go ahead and get started. Let me show you the matrix class really quick. So I changed this set transformation method just a hair, and all it is I basically took what was right here because M03 equals P.X was right here, and then this one was right here. All I did was I just put it like this, and I said if P does not equal null, then I set those two. And the reason for that is whenever we're doing uh, like inverse transformations, we don't need a point. or we don't need the position. We only need the rotation and the scale. And that's what we're going to be doing when we're parenting, is inverse transformations. So it's almost exactly the same, but it's negative rotation and then dividing scale and all this other crap. And I've also got, I set this up. You guys do not have to. I just set it up just so that we have something to look at, so that we can physically see that it's working. And it's basically just saying, it's finding the game object that I called scene. And if I push R, then I'm just rotating clockwise. If I push M, then I'm just moving it to the right. And world space, not local space. All this stuff I have doing it in world space. If I push S down, then if my scale is 1, then I'm changing it to 2. Else, so basically if it's already at a scale of 2, it sets it back down to 1. Same thing with P. If I push down on P, then I'm finding the game object called sprite. And if the parent of the game object sprite is the master, which I need to change that to null instead of master, then I'm setting the sprite, setting its parent to G, which is the scene game object. If the parent is already the scene game object, then I'm setting the parent to null, which of course we know as master. Which, let me go ahead and change that, because I did not do that yet. Let's see here. I'm going to say if parent does not equal master, then return parent, return null. I think. Hopefully I don't run into any issues from doing that. But we don't want to check it against master instead of null. We always want to check it to see if it's null, not set to master. Okay. I mean, I'm sure it doesn't, it's not going to affect you guys, but just for me. All right. So that's the part that I added in core, which you don't have to worry about any of that, because I'll be showing it to you. All right, and I did create a new method inside of mathf, and it's called the wrap method. Now, what a wrap method does is it wraps a value between minimum and maximum. So it's kind of like clamp, except for like if the value that you're trying to clamp is lower than minimum, that it clamps it off at minimum, so it returns 0. If it's higher than maximum, then it returns maximum. Instead, what wrap does is you take the value that you're wanting to wrap, and if it's below minimum, then it takes whatever is lower than minimum and it subtracts it from maximum, and same way in reverse. So if it's higher than maximum, then it returns minimum plus whatever was left over from maximum. And this is just an easy way of doing it. And I went ahead and created this variable right here, which is private, just so that I don't have to keep on creating it. And so I basically just say remainder equals maximum minus minimum. And that just gives me the remainder, what's below that. And then what we're doing is we're returning, and inside of brackets here says value minus minimum, percent or modulus, remainder plus remainder, and then percent, modulus, remainder plus minimum. And so that clamps it inside of there. So if you're wanting to, what is it? If you don't want it to be set to, because right now, minimum, like if we call this function, because we're actually calling this function for rotating, so we don't want anything to go past 360. Once it hits 360, I want to circulate it back to 0. And if anything's below 0, it needs to circulate back around to lower than 360. I don't want it to ever hit 360 because 360 is 0. So it can only return numbers between 0 and lower than 360. But if you wanted, say you're wrapping something and you wanted to have 360 as the highest, let's say you're doing like a volume kind of thing or something, I don't know, but whatever it is, if you want that number to be higher, like to the exact number that you're wanting the max to be, then you would just say maximum minus minimum plus 1. That's it. So just so you know that. I mean, or you could just pass in a higher number right here. So instead of 360, you'd pass in 361. Or, I don't know, something like that. Okay. So now to the actual coding of this. So inside of the inspector, I have actually changed these to local position, local scale, and local rotation. So local position, local position, local scale, local scale, local rotation, local rotation. So nothing else changes inside of the inspector. It's just those 6 entries. And that's because inside of the editor, I want to see the local transformation versus the global transformation. And that's all it is. If you've ever used other engines that has parenting, then you would see they do the same thing. And here is where the full-on magic happens. Because before, that is just what we're seeing in the editor. Now, I have changed how these work. So before we had position, we had scale, and we had rotation. Well, I changed how these work. So right here where it's position vector 2v, it's actually going to call position v.x, v.y. So it calls this method. That way we only have to write this code inside of here in this method. And I did the same thing for scale. It calls scale v.x, v.y. Yeah, I didn't have to do it with rotation because we're only using a float. Now, inside of the actual method that has the code. So before I was setting dirty to equal 1, position.set xy, and then doing a few other stupid things, and then, yeah, all that crap. Well, now all we're doing is we're saying position.set, and yes, we are setting it. So it'll say position.set xy, and then we're calling recalculate local transform. So if you want, if you're going through this, just go ahead and create this method and just leave it empty for now until we get to it. Now this is for position. Now we basically do the exact same thing we do with position, but now it's local position. So what you're going to need to do is under here just put local position as a new vector 2, local scale is a new vector 2, and local rotation, of course, equals 0. I'll go ahead and get rid of that so they're just bumped up against each other. You will also need this right here. And this is a temporary matrix that we're storing as static. And all this is doing is giving us something that we can temporarily use to do some mathematics for inverse transformations. That's all it's there for. Just so that we don't have to create a whole new matrix every time we do the calculation. Alright, so back to this. So here we do the exact same thing we did with position, except for we call local position v.x, v.y, which is just calling this method. And then here we're saying local position.set xy, and then calling recalculate global transformations. And you can see, make sure you don't mess this up, recalculate local transformation whenever we call position, but whenever we call local position, we call recalculate global transforms or transformations. Because anytime we update locally, then we need to recalculate globally. If we update globally, we recalculate locally. And that's exactly the same as how this is set up. It's set up exactly the same. This method calls this method, and then this calls scale.set xy, recalculate local, and then right here it's same thing, like it's just all the same as how it was for positions. And as for rotation, whenever I'm setting the rotation, I am setting rotation equals mathf.wrap, which was that method that we created. I'm passing in v, which is the value we're actually rotating it to, 0, and then 360. And then we're recalculating the local transformation. And then the same thing down here for local rotation. Local rotation equals mathf.wrap v0 360, just like before, except for we call recalculate global transformations. So for recalculate recalculate local transformation, basically this is only ever called once, and it's on the object that we're moving. All the other objects in the scene, or I should say, the children of that game object. So it's children, grandchildren, great grandchildren, blah blah blah. However, you have that set up, it's all going to call recalculate global transformations. This method will only be called on the object that is actually doing the moving. So on recalculate local transformation, what we're going to do is, of course, set dirty to equal 1. That way, if anytime somebody tries to grab our matrix, it'll update the matrix. And we're setting local scale to equal scale.divide parent.scale. So scale's a little tricky. It can be kind of a pain in the butt to actually get it right. And it was actually screwing with me whenever I was typing this up. So engines like Unity, they don't have global scale. I mean, I'm sure they do, they just do not give us access to it. They have something called lossy scale, which I don't know how in the world they type that up. I don't know if they're just a bunch of idiots or what, but because you basically calculate it just like you do local rotation and local scale. If you have the local scale, you obviously know the global scale. So I don't know what in the world, and you have to have the local scale or the global scale to pass it into the freaking shader. So I don't know what their problem is. But for us, we are going to have a local scale and a global scale. So after we set the local scale, we are going to set the rotation. And of course, local rotation is going to equal mathf.wrap rotation minus parent.rotation 0 and 360. Because just like before, we want it 0 or higher or less than 360. So to calculate rotation, all it is just our current rotation, like our current global rotation, subtracting the rotation or the global rotation of our parent. And that's how you get a local rotation. You don't have to do anything special. As long as your parent's rotation is set and your global rotation is set, which the only time we call recalculate local transform is after we modify the global scale position rotation methods. So everything should always be set. Then we can actually calculate a local rotation. And here's where the temp variable comes in. What we have to do from here is we need to we basically need a base temporary matrix to do an inverse transformation matrix. And what this does is our transform point method, it takes a method in local space and gives us global coordinate systems. Well, if we're doing parenting and whatnot, Or if we know the global position, but we do not know the local position, then what we need to do is we need to take the global position and transform it into a local transformation matrix. And that's exactly what this is doing right here. So I'm saying temp.set transformation null, because how I showed you in the matrix class, not everything is going to have a position. So our inverse transformation matrix is actually going to have to be at vector 2, 0, 0, which we don't need to set that because it's, well, our temp variable should always have a 0 position. So we're going to pass in null, and then inverse transformation matrix. So obviously we need a negative rotation. So negative parent.rotation, because we're calculating this matrix based off of our parents. And for here, I'm just going to say new vector 2, 1, 1, which I need to create a method that allows me to pass in just 1, 1. Dot divide. Oops, I moved that. Parent dot scale. So I'm basically taking 1 divided by the parent's scale. And the reason for this is that the transform point method right here is using it's transforming it in a way that it's later on going to be multiplied by the scale already. So what we have to do is we have to subtract that so that we get the correct position. If we don't, it's actually going to what do you call it, when it doubles itself every time you parent and unparent. So if I'm setting it over at 2, 2, if I unparent, it's going to go to 4, 4. If I parent again, it's going to go to 8, 8, and whatnot. And that's if the parent's scale is at 2. Then it just doubles itself every time. If the parents or the one that you're unparenting and parenting to, if it's say 3, it's going to multiply the position by 3. So that's why we have to do this division calculation. And then to set the local position, we're saying local position dot set temp dot transform point position dot subtract parent dot position. And that gives that finishes off our inverse transformation matrix in order to get global transformation and turn it into local. So then at the very end right here, we're going to loop through all of the children, and then we need to call children.getI.recalculate global transformations. So that's what I mean. If we call that, there's at no point in time are we going to loop and say, okay, all the children call local, because it just doesn't work like that. So children.getI.recalculate global transformations. So now for global transformations, we're going to say recalculate global transformations, and we're going to do just like how we did up here. We're going to set the dirty to true, or 1. Now we have to set the scale, because we always want the scale first. Whenever we're calculating transformation matrices, we always do scale last. Well, whenever we're basically doing it inadvertently, we want to do it first. So scale equals parent.scale.multiply local scale. So that's pretty easy too. It's just taking the scale of our parent and then multiplying it by our local scale, because our local scale we already have because we haven't touched. Then we're going to set the rotation, which of course is going to be mathf.wrap, and then to calculate our rotation, our global rotation, we're going to take our parent's global rotation and add our local rotation. And of course we're going to wrap that to 0 and 360. And to set the position, it's just a normal transformation. So it's position.set parent.matrix.transform point local position. So we're using our parent's transformation matrix and we're transforming the local position of this object. And then after here, we're looping through all the children of this object and telling the children, or telling each child to also recalculate its global transformations. So that way, like, say this one right here, I changed the position or whatever. So it's going to loop through, and of course it's going to tell this one to do global, or recalculate its global transformation. Or wait, this one. But this one is also a child of that one, and then this is a child of that one, so it just kind of iterates through and calls all of these. And you'll see me use this a few times. You don't want to do it all the time, but it is good to do it sometimes. And if you don't do it right, you can crash your computer, and it's a big nightmare. But it's basically a method that calls the exact same method. If you don't do it right, it's going to infinite loop and be a big disaster. All right, so underneath that, we also need a recalculate method. So what the recalculate method does is it's going to loop through all of the children of the master game object, and it's going to call recalculate global transformations for all of the master's children. Now this method is only going to be called once, and this is after everything. Because, for instance, if we do not have this, then it doesn't properly update after we load a scene. So immediately after we load a scene, it's not going to show our actual values until we actually click on the objects themselves, and then it'll update. So what we have to do is we have to recalculate every time we load a scene. And also down here under parent game object G, right here at the very end, we're going to recalculate the local transformation of the object that is about to get parented. Yeah. And that is it. Let me see here. I think I'm missing something. Game.engine, scene manager. Yeah, right there. Okay, so inside of the scene manager, under load scene, scroll down here, and you'll have this try catch statement. in the load scene method. So down here, it'll say while line equals br dot blah blah blah. At the bottom of this one, we're going to write gameobject.recalculate. And that's the only time that method is actually going to be called. And like I said before, that is just to ensure that all of the master's game objects are recalculated. So now whenever we run this, hopefully I do not run into an issue with changing that parent, because I did that on the fly, and then after doing it, I remembered that some things may actually call it, but it looks like it's good. I don't see anything. All right, give me just a second. Hold on. Okay, so there was an issue, just like I thought. So inside of the editor, so if we click on that at 263, then it's going to take us here. Here I say if g.parent does not equal master, what I need to do is say null instead of master, because now we're returning null if the parent is master. And really, you know what? I'm going to do that another episode. G equals master. Where is... Oh, right here. For now, I'm just going to remove that. But keep in mind, we're going to do that in the future. Except for at this moment in time, I don't know exactly what we need to change, because we've been using that for so long. We've been using it for almost a year now. So I don't know exactly where I put that checking if master, or if the parent is the master. And where was it that I put that other check at? CMAS. I did that in Matrix 4X, didn't I? Yes, I did. If P does not equal gameObject.master. Wait. What did I just do? If P does not equal null. I know I wrote that somewhere. I just don't remember where I wrote it at. There was somewhere where I'm still checking. It's something that we just did. I don't know. Let's see. Should go back to normal now. No. Okay, give me just a second. I don't know what I did. Okay. I can't believe this, but doing that whole parent equals null stuff that I was doing instead of checking if the, just basically leaving it the same, where parent returning parent instead of returning null. Apparently, whenever I did that, it deleted my scene. That's why we aren't able to actually see anything, because, well, it deleted everything in it. Yeah, so don't do that. Just leave it the same, and I will figure this out and figure out what all we need to change in order to make that return null instead of parent in the future. So so right here, whenever it's returning parent, just make it return parent instead of return null. And yeah, and over here, instead of it saying g2.parent equals null, just I'm doing that. I don't think I changed anything in any other scripts regarding that. But so really quick, because we're already up there in time, it's gonna suck loading this from my phone. But just so that we can actually see it working, and I'll go ahead and save it as well. Just say new game object. Let's name this one's scene. Oh, I also need a camera. Oh, no, not changing X. So you'll actually see me setting up a scene anyways. Camera. Come on. I'd like to add engine.camera. And let's do, because I have to set it up exactly like how or not exactly, but with the same name values. This is Sprite. That's what it was. I'll add the component. A Sprite Renderer. So engine.Sprite Renderer. And the sprite is, hold on, sprite brick. And just so that we have something for the scene, I'll add that on there as well, and I'll just make it small. Sprite Renderer. Oops. Engine.Sprite Renderer, not just Sprite Renderer. Engine.Sprite Renderer. And for this one, I'm going to do a brick as well. Except for the anchor, I'm going to set it to 0.5. 0.5, that way it's in the middle. And I'm going to no, I'm not going to shrink it. say the position, I'm going to set it to 40, 40. And let's actually crank this up. Sprite, put it at a scale of 2. Let me go ahead and save this scene. Copy, paste, and I'm going to say just in case. So just in case it deletes it again, I have a backup. Or just in case I do something in the future later that accidentally deletes my scene, I'll have a backup. I forgot to do that before, I think. Okay. So if I hit P, there we go. So as you can tell, it parents it and changes its position as needed. So you'll see over here, if I hit P, it will, it'll stay the same because it's actually, here, I need to move this over. Let's move up, not P, M moves it. So as you can see, whenever I hit P or M, it'll move it together. If I hit R, it'll rotate with it. If I unparent it, it should stay there. But these numbers will change over here because it's local. Yeah, see? Yeah, so it's working exactly as intended. Let's unparent it. Click scene, I'll rotate. Just so that you can see that it is now not rotating with it. And I'll hit M to kind of move it over. Let's parent it again, and as you can see, bam, it's back to being parented. So that's pretty cool, right? Outside of that little hiccup we had with the parenting thing. All right, so I think we need to work on some things next week in the editor, because there's several things that I need to get done. Parenting was actually the last thing that I needed to get done runtime wise for the actual game tutorial for the engine. So now that the runtime stuff is done for at least the game tutorial section, we need to actually get to some spots where I can start it in the editor. So once we get the editor to the point now that we can actually full on go on and create something using the editor and without having to rely on actual individual files, then I can start the game tutorial. So I think some things that I need to work on is scenes and scripts do not show up in the assets window, and they need to. We can click, and I think I still have that screwed up, or maybe I only did it for something else, or I don't know, but it no longer selects like how it used to. I mean, it selects it in the inspector, but in here, it's all screwed up. Well, we're gonna have to fix that. We also need the ability to drag and drop. So let's say in here I have, because we're going to need a, what's it called? An object field, which this sprite right here, this variable, that should actually be an object field, not a text field or whatever in the world I called it. So it needs to be an object field so that I can either click on it and find it, or I can drag an object in there. So I would be able to say click brick and then drag it over here, release, and then it goes in there. Or let's say I click on brick and then I drag it into the hierarchy and I let go. It should automatically create a game object and all that crap. We also need to be able to drag these around. So let's say there's a game object variable over here. We should be able to drag a game object from the hierarchy into that variable. We should also be able to click and drag it onto an object to parent it or unparent it. There's several different things we still need to work on in the editor, and we will get to it. But I don't know exactly what we're going to do next. But we'll do something along those lines in the editor. That way I can start this freaking game tutorial that I'm just itching to make. But thanks for watching, guys, and I will see you on the next one.